Yes, yes. What did we discuss in the last class? In the last class, oh, sorry, I was teaching my sister how to write on this thing. So she scribbled on my notes. So in the last class, guys, we discussed about the centripetal acceleration, the tangential acceleration, and the total linear acceleration. What was the total linear acceleration? It was basically the resultant of AC vector and AT vector. Please remember, where only AC vector will be acting, it will be a uniform circular motion, and where AT vector will be acting, it will be a non-uniform circular motion. It will be either accelerating or it will be non-accelerating. Huh? Oh, decelerating. So let's do the third lecture today. Circular motion lecture. So in last class we did the acceleration. Chal, I'll give you some questions. No, 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 no. I wanted to give you to where did the relation AT equals to this, the relation, where does the relation come from? है ना? Guys, do you remember the relation I told you? I'll give you the relations where exactly the relations will come from. Right or wrong? We'll do the questions later. Guys, do you remember the relationship between linear velocity and linear? So, guys, everyone remembers this diagram, right? Suppose this is the circle. Control C, Control V. So, basically, this is the front view, and that is the top view. Front view, and this is the. So everybody knows this particular thing with the direction of different velocity. है ना? Can you see over here the velocity will always be acting tangential to this, right? Will the velocity always be acting tangential to this? Yes or no, guys? Hello? Will the velocity always act tangential to it? अरे हाँ या ना बोलते नहीं यार guys, can you please keep your phone on unmute? Aman, Nicolin, Sanya, Sarah, please unmute.
Yes, sir.
Aman, Nicolin, Sarah. Please unmute them. See, so if I have the velocity vector always tangential, so can you see if I connect this velocity vector, which is basically going tangential, so is it going like this? Can you see, guys, tangential velocity? Although it is not that much clear in this, but it is clear in the top view, right? Yes or no, guys? Is it clear in the top view? Guys, is this and this clear in the top view and front view? This angle should be 90 degrees. This angle is 90 degrees. Yes or no?
Yes.
So basically, if I draw a radius vector, is the radius vector like this from here to here? Is this the radius vector r vector? So can you see from here? This will be the velocity vector at any point, and this will be the radius vector at any point, at the same point, and this will be your angle theta. What is the r vector? Pointing from center of the circle to the point on the circumference. So that is basically a radius vector. What is the magnitude of the radius vector? The magnitude will be equal to the radius and the direction is radially outward. Please remember magnitude equal to radius and direction is radially outward. So I think this radius vector is pretty much clear to you. Now can you see over here the angle between the v vector and the r vector is basically how much? 90 degree. Yes or no, guys? Yes or no, guys? And can you see the particle is rotating which direction? The particle is rotating anti-clockwise, I guess. Is the particle rotating anti-clockwise? If the particle is rotating anti-clockwise, that implies this should be the in a sense of omega. So this is the sense of omega, and the what will be the direction of omega? Guys, the sense of omega will be in this direction, and will the omega be pointing out of the plane by right hand thumb rule, right? So if I draw the omega, will it be like this? This will be the direction of omega. It will be acting in this direction. So I think I have already cleared you about all the three vectors, right? Omega is coming out of the plane at this particular point. Yes or no, guys? Guys, is this clear? So from here,
Yes, sir.
we know this relation, the magnitude-wise relation we know, right? The vector-wise relation for this is basically omega cross r. Everyone was clear in when we were discussing vectors. Do you remember the cross product? Everyone remembers the cross product, right? Does everyone remember the cross product?
Yes, sir, kind of.
Kind of. So basically, in this, what do you do in your cross product? Here, the direction of v vector can be given by a right hand thumb rule. How will you apply that right hand thumb rule first? All fingers tip should be pointing in the direction of omega. So can you see every fingertip should be pointing perpendicular to the plane? So all the fingers are coming towards you, okay? From the screen they are coming towards you. Then curl fingers towards R. So when it is coming towards you from, I'll try to see, guys. First, all the fingers are coming towards me. Yes or no? And can you see when I curl them? When I curl, it is not visible from here. So it's like this. It is happening like this, right? So when it is happening like this, so can you see when I do in terms of R, my thumb points in the direction of velocity vector. Try to do this on your own. First, the omega should be acting towards you. So omega should be acting towards you. The radius vector is over there. So let's do one. Let's do one. what exactly I'm doing, I'm changing the direction of V so that you can apply that law easily. Let's say the particle is not rotating anti-clockwise. Let's say the particle is rotating clockwise. So when the particle rotates clockwise, then basically what happens? The omega will act into the plane. And omega will act like this. The velocity at any point, it will be acting. This will be your velocity vector. So can you see, guys? क्या हो गया तानिया?
She's very, very sad. You know, she recently must have had some.
Sir, I'm sorry. I'm so sorry.
So anyways, now can you apply the law, guys? Will you be able to apply the law? Please remember, I changed the direction of this. So even this will be changed. Yeah. So now everyone can see this is your velocity vector, this is your radius vector, and your omega vector is pointing into the plane. Now I think it will be easier for you to apply this. Can you apply it now? Guys, will you be able to apply it now? See,
Yes.
omega is acting into the plane. So all the fingertips should be pointing in the direction of omega. And now can you see the radius vector? Where is the radius vector? Where is the radius vector? The radius vector is like this, right? So omega se aata. Can you see my thumb is pointing in the downward direction? What can do? Yes or no, guys? Is this clear? Any doubt in this? So basically, this is your dot cross product. The direction you decide it like that. So I guess this is pretty much clear. The direction of V equals to omega cross R. Now let's talk about the relationship between this vector relation was important, right? From this vector relation we'll prove something. Now relationship between linear and angular acceleration in vector. Basically, I'm giving you proof for AC and AT. Okay. First, as we all know, just now derived, है ना? V is equals to omega cross R. Yes or no? Where R is the position vector. You remember the radius vector is nothing but position vector, right? Hello? Guys, is this clear? Everyone is clear about this concept. Na? Radius vector is nothing but giving the position, right? Was it giving the position vector? Are yes or no? So,
Yes, sir.
linear acceleration will be linear acceleration at any point And which acceleration I'm talking about? The total linear acceleration. So the total linear acceleration at any point A total, will it be equals to dv by dt? Just differentiate the velocity with respect to t, yes or no? So dv, v I can write it as omega cross r. Okay? And I don't know whether you remember this or not, but there was something called as product rule for differentiation. What was the product rule for differentiation? Differentiation of d by dt of 1 or basically u and v. I don't know whether you remember it or not, but if you multiplied by v was written by v into by dx plus u into v. ये याद था किसी को? Guys, do you remember this product rule in differentiation we did? कि
Yes.
सब भूल भाल गया. So anyways, this omega and r will do the same thing. So this will be first omega as it is. So we'll write a is basically equals to r as total cross. It should be written in order because it's a vector form. So omega cross r cross then r as it is. So cross r as it is. I haven't changed the order, guys. Can you see here? Here it was just a magnitude, so I did the u as it is, u front and this like this. But remember whenever it is in vector quantities, when applying product rule in vector quantities, don't change the order. Don't. Order means what? You don't write one first, one second. Just differentiate one and then write as it is the second. So when you do this, omega is basically what is position vector? The d position vector by dt. Is it equals to speed? Is it equals to linear velocity, right? So omega cross v. Position vector divided by time is nothing but linear velocity plus this d omega by dt is nothing but alpha, and this is equals to r. So remember this thing is your centripetal acceleration and this thing is your tangential acceleration. So do you remember this? A total vector is basically AC vector plus AT vector. ये याद है आपको? Where what was AC vector? AC vector was equals to omega cross V. And please remember the direction between omega and V, the angle between omega and V, how much? So 90 degrees. And similarly, tangential acceleration is alpha cross r. Can you see from where did we derive the formulas for centripetal acceleration and this thing? We derived the formulas from here. Okay. Please remember here. Yeah, by d vector is equals to d vector as the rate of change of position is so that's why we wrote dr by dt as d vector and d omega by dt as alpha. Please write them down. And from here you get your final answer, the total acceleration and the AC and AT which we discussed in the last class, right? So now is the derivation clear? Guys, now is the derivation clear? Where did you write AT as alpha cross r? Yes or no? Chalo, so write down some questions now. Then we'll discuss the centripetal force. And then we'll go into the mechanics part. Whenever you're done writing, just tell me. Guys, whenever you're done, just tell me. Okay? Okay. Radius equal to of radius 3 meters. At a speed given that v is equals to 3t square meter per second. Now find AT, AC, and A total at t equals to. Chalo, here goes on. Guys, whenever you're done, just tell me. Tell me the answer. Yes, guys, tell me what the answer. Anyone? If the tangential acceleration is nothing but dv by dt, right? So you can differentiate it. I told you this particular thing, differentiation, integration, do practice it a lot because it will be there in every chapter of your physics.
Sir, are you saying something? Oh, you're not.
No, I'm not saying anything. It's like you people,
Yes,
when
sir.
I ask you, you people don't say anything, so I thought of even I'll take classes on mute now. Everyone keeps their phone on mute, so even I'll keep my phone on mute. What's the point? What's the point? Hey, okay.
Sir, please talk. It is very, very weird environment over here. You're not talking.
I know. It should be like this. Now you understand my pain. I don't know whether you
Yes,
can or
sir.
not, but still, till the time everyone is not able to understand what I go through when I ask you people ki beta samajh mein aaya kuch anything and nobody replies, then till that time, this class will be on. No, Cyril, I'm not saying anything. I told you, no. Nicolin and Aman, you can put your call on mute, put your mic on mute. There is no need to, put it like on unmute now. Because I've been saying from a very long time कि भाई लोग please unmute कर दो. Whenever at least I reply, that time reply to me. उस टाइम पे भी कोई reply नहीं करता. It's like feel like I'm literally teaching, like in a silent class. So मैंने बोला let's do it this time. Let's keep a silent class this time. I'll just keep on writing. You keep on writing as well. And there will be no discussion, nothing. I'll just write. You will also write. Is this what you want?
Nope.
At least, yeah, reply
No,
at that
sir.
time when I ask you. Why is it? Is there anything which you? Why you keep on, keeping on mute? I don't mind, even if Sanya sings sometimes or laughs in between. I don't mind. Literally, I don't mind. But the point is कि यार when I ask
So
questions,
seriously, you don't mind, right?
no, I don't mind. Literally don't mind. मेरी क्लास में तुम खाना खा लो, I don't mind. But the point is, till the time, until and unless your attention is towards me, till that time you do anything, it's fine. But if I ask anyone any question उस time पे मुझे reply मिलना चाहिए. If that reply doesn't come now, it feels like literally I मतलब नहीं. I can go on with this type, I can just write the question, solve it in front of you. You people will just keep noting it down. Or I don't know whether you people are noting it down or not. At the end of the day, I'm sending the notes to you. So, sir, ultimately we have the notes. What's the point on even in writing? Now I'm getting this question. थोड़ा सा यार, थोड़ा सा sincere with चलाओ यार at least. I'm not
Sir, we are
saying
writing
anything.
notes, sir.
Yeah, I'm not saying anything. That doesn't mean it's like I can be the chillest teacher, chillest if that's even a word. The most chill teacher ever, and I can be your nightmare as well. I justify my name. इतना ध्यान रखना. It's like till the time everything is good, then everything is good. Once this third eye gets opened, no, so you don't know what happens when the third eye gets opened. And it's
Sir,
not
what
like
happens?
they wanna know what happens. है ना, ऐसा भी नहीं है. मैं एक इंस्टेंस तुमको बताता हूँ. Like when I was in Catalyst in Nashik, it was Saturday morning. And what happens in Saturday in Nashik, it's like the electricity is not there from morning itself. From morning till evening, there is no electricity. So it was like when I came to the class, it was like first lecture, second lecture, third lecture. I had 3 lectures in the morning and 3 lectures in the evening. So हुआ ऐसा कि when I reached at the center, the light was not there. I told the infrastructure guy, dude, please do something about the light. The AC is not working. See, it's a very small thing, it's not a very big deal. But the point was, I said to him, beta, the AC is not working. I said him once. He said, no problem, sir. I'm just going. I'll just go and get the diesel and get the generator working. I said, okay. After 1.5 hours, after one lecture, I asked him again. He didn't go. He didn't, do anything like that. So after 1.5 hours, again, I asked him, कि भाई क्या हुआ, light नहीं आई. So he said, कि नहीं sir, बस I'm going right now. I said, okay. This was the second time, and for the second lecture also, light was not, the electricity was not there. What happened in the third lecture? The third lecture was around 12:30 p.m. in the afternoon, and it was, it became way too hot, right? So when I entered into the room, it was like, a gush of hot air, it flew through it. So basically, I felt, like in night, खराब दिन. उसके बाद I said कि नहीं, I am not taking the class. Everyone go out. Everyone go your home. वहीं पे उस टाइम पे class cancel. And why the class was cancelled was not because of the garmi. It was because of the 2 times when I said to him, and he said कि yes sir, बस होने वाला है, होने वाला है. So the class got cancelled because of what? Of non-compliance. 2 बार. तो जाने दो. उस दिन क्लास
So
कैंसिल हो
we
गई.
will respond. Don't worry, we will respond.
तुम बोलते हो, आज बोलते हो, कल बोलते हो, बट 2 दिन बाद वापस से the same thing starts. And it's not only with me, it's with every other faculty. Every other faculty has the same thing. Literally every other faculty has the same thing to share whenever we have any meeting, so we just discuss the same thing. Yes, 11 people, they are not talkative at all. At least they don't even respond in the class. ऐसा होता. So please guys, until and unless you won't respond, we won't be able to help you. We won't be able to do anything. We'll be just coming, teaching, and going. There won't be any difference between your school teacher and me now. ऐसा होगा. They want that to happen because I personally don't want that to happen. See, it's like, why do I keep on giving you questionnaires? So many questions on a single topic. It's just so that whatever you are learning, your concept get clear. Although, please remember the questions will be like the past concept will also be mixed with what you are learning now. But at least here I'm giving you practice so that you will be relating things with what you study. It won't be like this chapter is something different only. Okay. Anyways, chalo, karo. So a particle moves in a circular path of radius 1 meter with an angular speed of given by this. Angular speed is given in terms of time. Now the question is find the angle between total acceleration and the centripetal acceleration at t is equals to 1 second. Please start doing. Yes, how will you do it? Anyone? What have they asked? Guys, what have they asked?
Sir, I don't know.
They've asked to find the angle.
They have asked to find out the angle. Where is the yeah. So they have asked to find out the angle, right? Angle between total acceleration and centripetal acceleration. For that you need the centripetal acceleration, and for finding out the total acceleration you need the tangential acceleration as well. So basically they have just given you omega and the radius, and they are asking you to find out everything. Shuru ho jao. Well, when is the class, by the way?
6:30, sir.
Yes, how will you do it? Do it one by one. First of all, AC. Let's calculate AC, centripetal acceleration. We know centripetal acceleration is nothing but what? Omega square r. Yes or no? Do you know these formulas or not? Is centripetal
Yes, sir.
acceleration v square by r and omega square r. So this will be equals to 2t square plus 1 square multiplied by 1. Radius was 1 meter. So from here you get AC as 4t4 plus
Yes, sir.
4t square plus 1. Is this your centripetal acceleration? And they have asked to find out your centripetal acceleration at t.
Your voice is lagging.
Yes, sir.
Is it clear now? सानिया क्या हुआ कि मशीन लगा ली क्या यस सर यस सर वाली? So अभी तो मैंने पूछा भी नहीं कुछ तब भी यस सर. So at t equals to 1 second, acceleration centripetal. Hello. Can you hear me now? I think my net connection went completely. Can you hear me now, everyone? So now the centripetal acceleration is basically 4t to the power 4 plus 4t square 2ab plus 1 into 1. So basically it will be this. So at t equals to 1 second, the acceleration will be equals to 4 plus 4 plus. I don't know. Net connection is doing something. Can you hear me now, people? My net connection is showing.
Okay, रहने दे, ले जा. ले नहीं चाहिए.
So
Sir, that's the reason we off our mics. Otherwise, our scene will be like Sanya.
no, it's okay. But at least
You
whenever,
realized.
when,
Nice.
whenever at least I'll tell you at least तब तक reply करेगा तो तुम तब भी नहीं करते हो. Every the